Alrighty, as promised, I'm going to go through this quiz practice and try to help you out. So first of all, when you have the square root of a negative like you do in this problem here and here, you can't just get rid of them. What you need to do is think, okay, the square root of 9 is 3. The square root of a negative makes it a -1 because you're thinking of splitting it up into this. And the core thing to remember is that a -1 under a square root now means I. And if you have an I squared, that has a value of -1. These are the two kind of core building blocks of complex or imaginary numbers that you need to keep in mind. So then here, this would be the same thinking. Root 4 root -1 is going to be a 2i. You multiply the numbers, you multiply the i's. So again, the I squared has a value of -1. So this is the same as 6 times -1. So ultimately my answer will be -6. Here I'm going to FOIL, and I'm going to treat it just like an x until they end up squared or something. So here I go. 3 times 2 is 6. 3 times -5i would be -15i. The insides would be a +8i, and then the last would be a -20. I times I is I squared. This is the piece you always have to watch on these because this now becomes -20 times -1, which has a value of +20. So the +20 and the 6 go together to be the numerical part, the real part. And then the two imaginary numbers can be combined because they are like terms. So I would get a -7i. And when you write your answer, you always put the real part first. And then after that, you follow it with the imaginary part. So it's always a plus or minus bi, and in that order. That's how you write a complex number. All right, how about here? When you're doing division, you're really going to need to multiply by what we call the complex conjugate. So know that. And a conjugate only changes the sign of the I value. So I would have to use 5 plus 2i. Whatever you multiply the bottom with, you multiply the top by as well. You're going to FOIL the top, and you're going to FOIL the bottom. Keeping in mind that you do the bottom correctly, it should come out to be a number. That's the entire point, is that you cannot have an imaginary number on the bottom since it's representing a square root, like up here. And back from in Algebra 2, you may recall that you can't have a square root on the bottom. So I'm going to go ahead and FOIL the bottom. Whoa. FOIL the bottom first. So I'll have 5 times 5. Then my outside's 10i. My inside is -10i. And my last two would be a -4i squared. Okay, these cancel as they should with conjugates. This turns into a +4. So in the end, I get a 29 on the bottom because this number and this 4 that I got can go together. So that should always happen. Like I said, it's going to turn into a number on the bottom. Now the top will stay messy as a complex number, but nobody cares. So if I do the top, I'm going to have 4 times 5, which is 20. The outside is 8i. The inside is 15i. And the end is 6i squared. So this has a value of 6 times -1, so -6. That can combine with the 20 to become 14 for the real part. And then my imaginary numbers here in the middle can go together, and they will add up to be a 23i. Now, I can go back and say, all right, I'm going to reduce this if I look at this triangle of numbers and something would come out of each corner. But hang on one second. Nothing does because those numbers are prime. And so I would just end up with 14 plus 23i all over 29 as my final reduced answer because it doesn't really reduce any more than that. Don't make this one harder than it is, and don't immediately FOIL. You got to really think. You can't just be like, oh, there's parentheses, I'm going to FOIL every time. This isn't asking you to do that. This has a -1 in front that has to be distributed. So I have my 2 minus 7i. This distributes to be a -3. These actually cancel out to become a +4i. I'm going to put my real numbers together, so 2 minus 3. And then I'm going to put my imaginary numbers together. So this negative 7 and positive 4 will turn into a minus 3i. I can't combine, condense, or do anything differently. That's my final answer. Okay, so over here I would have had negative 6. I would have had for number 2, 26 minus 7i. Here I would have for number 3, 14 plus 23i all over 29. And then negative 1 minus 3i, because I want to keep them in this a plus or minus bi format. So now I can determine the number of zeros. Okay, keep in mind that the degree you have equals the number of zeros. And from our previous notes, you can look back at the 2-5 notes. They split into real and imaginary, but the catch is that the imaginary come in conjugate pairs. So if 2i is 1, so is negative 2i. If 1 plus 3i is 1, then so is 1 minus 3i. And when something comes in pairs, you can only have an even number of them. So I can have none, or 2, or 4, or 6. So that's what this problem number 5 is referring to. True or false? It is possible for a 7th degree polynomial to have only one real zero. So that's going to mean that your degree is 7, and if it splits into having one real, that would leave you with 6 imaginary. And since they have to come in pairs, that could be broken down into 3 pairs. So that is true. That is possible because they have to come in pairs, and that's possible since 6 is a even number. If the question had said that you had 2 real, that would leave 5 that were imaginary, and then that is not possible because the number 5 can't be broken down into pairs because it is odd, and you always have to have an even number of imaginary zeros because they have to come in pairs. So that's a good thing to know. Here, if 2 plus 3i is a 0, then the conjugate would also be a 0, but they gave me this. That's not the conjugate. In the conjugate, you only change the sign of the I, which they did do, but they also changed the sign of the 2. So these are actually total opposites. So this is going to be, it says if 2 plus 3i is a 0, then is this a 0? And the answer to that is going to be a no. And the reason is going to be that they need to be conjugates. So they're going to be conjugate pairs. So your real other 0 would be positive 2 minus 3i. If you were given 2 plus 3i, then your other 0 would be 2 minus 3i. So every time they give you one, you know the other. In 7, it's saying if 5/3 is a 0, is 3x minus 5 a factor? Well, that goes back to these little 0 factor tables I've been making since the beginning. So they're basically saying if this is your factor, is this a 0? Does that work? Well, the only way to know is to plug it in. So they're basically saying when you have a 3 and you plug in 5/3, I'm just following this right here, and then subtract 5, does that equal 0? It's asking you. It's easy when it's like x minus 2, and this is a 2, and you can say, yeah, when I put a 2 in there, 2 minus 2 is 0. But with the fraction, it can be more confusing. So you have to maybe plug it in and actually see, well, this 3 on the top and bottom cancels. Then I have 5 minus 5, which does equal 0. So that would be a yes. And then it says, if not, what is the factor? Well, that is the factor because it worked out and I got a 0 from it. Okay, so these are going to take a little bit of time. Let's see here. So it's saying find all the zeros. That's going to be 4 of them. I'm going to have 4 zeros because that's what the degree is. And it says given that x minus 3i is one of them, one of my factors. So if x minus 3i is a factor, then I know that 3i is a 0. And if I'm given that one, I also know negative 3i is a 0 because they come in conjugate pairs. So I know 2 of the 3. So I'm going to have to start my work. This is going to take up some space, so hopefully I can make this all fit in here. I'm going to start by dividing synthetically with that negative 3i, or positive. So I'm going to put a 3i here. Now, if you've been keeping up with your homework, copying my coefficients, you have done this before. If you have not been keeping up with your homework, then this is going to be the first time through it. I would recommend you go back and practice it some more because it's a little bit tricky. So I'm going to drop the 1. I'm going to do my synthetic process, which is to multiply these two. But then here in this column, this is a negative 2 minus a 3i, and they don't actually go together. So they stay as a whole complex number. Now, I still have to do what I always have to do and take this box times this to get the answer that goes below the 8. I'm going to show my work for that over here because it's going to take up a little space. So I have to go back to what I learned in my practice with complex numbers. This distributes to negative 6i minus 9i squared, but that turns into a plus 9. So ultimately, this becomes... this is going to become, wait a second, I feel like that should be negative. Negative 6i minus 9i squared positive 9. Oh, I know. Okay. So this is going to be a 9. I'm confused because I feel like I did this problem with people and it was different than this. So this is going to be a 9 minus 6i. That is definitely not the same. I used to get a negative 1. Let me think for a sec here.